So far in this series, we have looked at linear functions and quadratic functions. Both of these functions are actually special cases of a more general type of function called a polynomial function. A polynomial function is a function that can be expressed in the form like this. Here, n is called the degree of the polynomial and the a's are called the coefficients of the polynomial. The individual monomials that make up the polynomial equation are called terms. The linear function on the left is a polynomial function of degree 1, as the highest power of x is 1. Similarly, the quadratic function on the right is a polynomial function of degree 2 because the highest power of x is 2. A third degree polynomial function would look something like this. Next, let's discuss some important properties of polynomial functions. When the number of terms in a polynomial function is limited to just 1, the function is called a power function. Here are a few examples of power functions. Notice that the degree of the function is equal to the power of x. If the degree of a power function is even, the function will have a shape similar to this. There is nothing new here. This is just a quadratic function we looked at in the previous video. But the nice thing about power functions is that if we know how to graph one of them, we can graph any power function. As we increase the degree of the even power function, the graph will become steeper, but the general shape will remain the same. Same is true for odd power functions. As we increase the degree of the odd power function, the graph will become steeper, but the general shape will remain the same. Finally, let's discuss another important aspect of polynomial functions called end behavior. The end behavior of a polynomial function describes the behavior of the function as x approaches positive or negative infinity. It would be easier to understand this concept with an example. Consider these two polynomial functions. If we were to plot these functions with a small value of x, we would see the graph of both functions are moving in somewhat different directions. But as we increase the value of x, the graph of both functions will start to look similar. This is because the term with the highest power of x dictates the end behavior of both functions. Since the highest power of x in both functions is 3, the end behavior of both functions will be the same. The reason it's called end behavior is because the behavior of the function is observed at the ends of the graph. And that's all there is to know about polynomial functions for now. We will cover more properties of polynomial functions as we progress with this series. If you like this video, please give it a thumbs up and subscribe to the channel. In the next video, we will look at the rational functions. Thanks for watching.